Hi everyone, welcome back. So the best and most efficient way to perform good at math is very simple. It's just doing as much practice as you can. So throughout the course of the next few videos, we'll just be doing practice questions on all the concepts that we've covered so far. So that way you feel more familiar with the concepts and you know when to apply what concept. So let's get started. So here we have the limit as x approaches 2 of x cubed minus 8 divided by x squared minus 4. So obviously at first we should try and plug in the value of x over here. So 2 cubed is 8. So 8 minus 8 divided by 2 square is just 4. So divided by 4 minus 4, that gives us 0 over 0, and we know that this is indeterminate. Okay, so pretty obvious in this case that what we need to do next is to factor. So we know the denominator is x squared minus 4. So this is the same thing as x squared minus 2 squared, right? Because 4 can be written as 2 squared. So now the difference of 2 squares becomes more obvious. So that means we can write this as x plus 2 times x minus 2. So is that it? Not really, because the denominator in this case is x cubed minus 8. So if you look closer, you will see that this is indeed a difference of 2 cubes. Okay, so recall the formula for difference of 2 cubes. We say that when you have a cube minus b cube, we can write this as a minus b multiplied by a square plus ab plus b square. So using the same formula, we can write x cubed minus 2 cubed as x minus 2 times x square plus 2x plus 2 square, which is equal to 4. Okay, so now let's rewrite our original limit. So we can write this as the limit as x approaches 2 of x minus 2 times x square plus 2x plus 4 divided by x plus 2 times x minus 2. So x minus 2 and x minus 2 will cancel out. So that leaves us with the limit as x approaches 2 of x square plus 2x plus 4 divided by x plus 2. So let's try and plug in at this point. So this gives us 4 plus 4 plus 4 divided by 4. So that is just equal to 12 over 4, and that equals 3. So that's it. So in this case, we know that the limit as x approaches 2 of our function is equal to 3. Okay, so now let's do a second example. So here we have the limit as x approaches 4 of x minus 4 divided by 3 minus the square root of x plus 5. So first things first, we should always try to plug in. So this gives us 4 minus 4 divided by 3 minus 4 plus 5, 9. The square root of 9 is 3. So this gives us 0 over 0, which is indeterminate. So what should we do in this case? We know that there's a square root, but in this case, x is just approaching 4. It's not approaching infinity. If x was approaching infinity and we had the square root, then that's a whole different discussion. So here we know x is approaching 4. We have a square root. There is no factorization or any other technique we can apply. So what does that say? That we have to go for the good old conjugate method. Okay, so what we do here is that we take the limit as x approaches 4 of our function, and now we multiply both the numerator and denominator by the conjugate of the term that contains the square root. So in this case, we know that our denominator over here contains the square root. So I'm going to take the conjugate of this whole denominator and multiply it to both the numerator and denominator. The conjugate of 3 minus the square root of x plus 5 is just 3 plus the square root of x plus 5. Again, remember with conjugates, we just flip the sign in between both the terms, right? So we are just going to flip this sign, okay? And I'm going to multiply the denominator by the same conjugate. So mathematically, we're not doing anything because this and this can just cancel out to give us 1. So now let's just do our simplification and get done with this. So this gives us the limit as x approaches 4. I'll just write it down more neatly. So we have x minus 4 multiplied by 3 plus the square root of x plus 5 divided by 3 minus the square root of x plus 5 times 3 plus the square root of x plus 5. Okay, so now remember, when I have a square minus b square, I can write this as a plus b times a minus b. This was the difference of 2 squares. If you look closer, you're going to see that this here is your a, and this square root of x plus 5 here is like your b, right? You have a negative sign here, you have a positive sign here. If you look closer, we can sort of match this thing to the difference of two squares over here. So currently our denominator over here is written in this format, right? So if there is an equal signs, that means that we should be able to write it in the a square minus b square format as well, right? So instead of having two separate brackets, right, we have the a plus b in this side and we have the a minus b over here. We can just write it as a square minus b square. So we know in this case our a is equal to 3 and our b is equal to the square root of x plus 5. Okay, so if I were to write this as a square minus b square, so that's just 3 square minus x plus 5 under root square this. Okay, so this now gives us 9 minus the square root will cancel with the square, x plus 5. Again, this bracket is pretty important, so that gives us 9 minus x minus 5, which then becomes 4 minus x. So what we just did here is that we took the whole denominator, right? We used the difference of two squares to sort of simplify this whole long ugly looking denominator to a simple 4 minus x. Okay, so that means that our limit now becomes the limit as x approaches 4. I'll write down the numerator as it is, divided by, now instead of writing this whole long ugly denominator, I can just write 4 minus x. Okay, so is any sort of cancellation obvious over here? Not really, right? Because in the numerator we have x minus 4, but in the denominator we have a minus x plus 4. The sign in the numerator is the complete opposite of the signs in the denominator as far as this term over here is concerned. Okay, so what can we do in this case? We know that it's pretty close and we can just make some some small tweaks and kind of in a smart way be able to cancel this. So the simplest thing you can do here is multiply both numerator and denominator by -1. Okay, so if I'm multiplying both numerator and denominator by -1, it's just -1 divided by -1, which again is just 1. So mathematically we're not changing the function, or we're not changing anything, to be honest. So if I do that, this now becomes the limit as x approaches 4. So what you do next is that you take this negative sign and you multiply it to either this x minus 4 or to this 4 minus x, not to both of them. Okay, because if you multiply the negative sign to both of them, then you've kind of done nothing, right? You haven't worked around with this. Okay, so you multiply it to only one of them to flip the sign so that we can cancel both of this. So in this case, let's just say that I'll multiply this -1 to this numerator term over here. Okay, so what is -1 times x minus 4? So that means this becomes minus x plus 4. Then I'll write the rest of the numerator as it is, divided by, now this 4 minus x, I'll just write it as it is. And what else? Let's not forget this -1. So I'm not multiplying the denominator 4 minus x with the -1, because if I do that, then I won't be able to cancel it with the numerator. So if you look closely now, you'll see that the numerator just becomes -x plus 4, and the denominator here is also -x plus 4. So that means that now I can cancel the numerator and denominator, and that just leaves us with the limit as x approaches 4 to be 3 plus the square root of x plus 5, the whole thing divided by -1. Okay, so it might seem a little confusing, but if you look a little closely and if you try out multiplying both of them with the -1, you'll sort of understand why you only multiply one of the term with the -1 and you leave the other -1 as it is. So now at this point it's fair to try to plug in. So this just gives us 3 plus 4 plus 5, which is 9. So 3 plus the square root of 9 divided by -1. So that is just -6. So therefore, in this case, our limit equals -6. Okay, so moving on, what do we have here? So here we have the limit as x approaches -infinity of a polynomial divided by another polynomial. So we know that this is a rational function. So what did we say we need to do in this case? Remember, limit at infinity, whether if it's positive infinity or negative infinity. And if you have a rational function, so then you multiply the numerator and denominator by the reciprocal of the highest power of x that is in the denominator. The other way to think of this is that you divide the numerator and the denominator by the greatest power of x in the denominator. So reciprocal is the same thing as saying dividing by something. Okay, so here what is the greatest power of x in the denominator? So we know that the greatest power here is the x to the power 4. So I'm going to take this greatest power of x only. I'm going to ignore its coefficient. I'm going to ignore its sign when I multiply the numerator and denominator by the reciprocal of this term. So here I'll just multiply the numerator by 1 over x to the 4 and the same thing for the denominator. Okay, so that gives us the limit as x approaches minus infinity of 2x to the power 5 divided by x to the power 4 plus 12x squared over x to the 4 minus 3 divided by x to the 4. The whole thing divided by 3x to the 4 divided by x to the 4 minus 2x cubed over x to the 4 plus 4x divided by x to the 4 minus 2 over x to the 4. Okay, so if you try to simplify this, that gives us the limit as x approaches minus infinity. So the x to the 4 will cancel with x to the 5 to give just the 2x at the top. Okay, so this becomes x to the power 1. The x square will cancel with the x4 to give an x square in the denominator, so that becomes 12 over x square. 3 divided by x to the 4 just remains the way it is. The x to the 4 will fully cancel with the x to the 4 here. The x cubed will cancel with the x to the 4 to give a single x in the denominator, so that becomes 2 divided by x. The x will cancel with the x to the 4 to give an x cubed in the denominator there. And 2 divided by x to the 4 just remains as it is. Okay, so now that gives us 2x plus 12 divided by x squared minus 3 divided by x to the power 4 divided by 3 minus 2 divided by x plus 4 over x cubed minus 2 divided by x to the power 4. Okay, so now we should try to plug in. Let's start with the second term here. So 12 divided by negative infinity square is just going to go to 0. 3 divided by negative infinity to the power 4 is going to be 0. 2 divided by negative infinity gives 0. 4 divided by negative infinity cube also gives 0. And finally 2 divided by minus infinity to the power 4 also gives us 0. Okay, so that now leaves us with 2x divided by 3. So at this point, there is no further simplification that we can do. So that just means that we got to plug in the value of x. So we have 2 multiplied by minus infinity divided by 3. So that just gives us minus infinity. So therefore, in this case, our limit is equal to negative infinity. Okay, so final question for this video. And yeah, this is the hard one. So the limit as x approaches infinity of 5x squared minus 13x plus 5 divided by the square root of 4x to the power 4 minus 3x cubed plus 3. So right away, if you try to plug in infinity into the value of x, you're just going to get an infinity over infinity, which is an indeterminate value. So what do we do in this case? So what type of function is this first? So we know that this is a radical because there's a square root, and we are approaching infinity in this case. So we don't need to do the conjugate method in this case, right? Keep in mind that we say that if you're approaching infinity and you have radicals, then there is a very strict sort of rules that we got to follow to solve this, okay? So what do we do? So you find out the greatest power of x in the denominator, and you multiply the numerator and denominator by the reciprocal of the greatest power of x. In other terms, you divide the numerator and denominator by that greatest power of x which is in the denominator. So in this case, what's the greatest power of x? If you look closer, you're going to see that you have an x to the 4 over here. So is it fair to say that x to the 4 is the greatest power of x? No, right? Because we have a square root. So the greatest power of x in this case is the square root of x to the 4. Okay? The square root of x to the 4, remember we said that the square root of a square is not just equal to the positive value, is equal to the absolute value of that answer. So the square root of x to the 4 is not just equal to positive x squared, it's equal to the absolute value of x squared. So hence we know that the square root of x to the 4 is equal to the absolute value of x squared. So what is the absolute value of x squared equal to? If you want, you can go on and write the whole definition and deduce the absolute value, or you might also just do it in a faster way. In this case, we know that this power over here is an even power, okay? So if the power is even, regardless of what the sign of x is, even if x is positive or negative, but if you're multiplying it an even number of times, the resulting answer is always going to be positive. So in that case, since this power is even, it's fair to say that the absolute value of x squared is just going to be equal to x squared. This was pretty much explained in the video concerning limits at infinity for radicals. Okay, so in this case, we know that the greatest power of x in our denominator is equal to x squared. So what do we do now? So we multiply the numerator and denominator by the reciprocal of this greatest power. Again, when we multiply by the reciprocal of the greatest power, we do not need to consider the coefficient of the greatest power, neither do we need to consider the sign of the greatest power. So let's try and do that now. So that gives us the limit as x approaches infinity of our function. I'll just write it down. And now I'll multiply both of this by the reciprocal of the greatest power, which is x squared, Or you can think of it as I'm dividing both the numerator and denominator by x squared. It's the same thing. So 1 divided by x squared over 1 over x squared. Okay, so now let's perform this multiplication. Keep in mind that the 1 over x squared multiplies to the whole numerator and to the whole denominator. So this now gives us the limit as x approaches infinity. 5x squared divided by x squared is just 5, minus 13x over x squared is just 13 divided by x, plus 5 over x squared, multiplied by the square root over here. So 4x to the 4 minus 3x cubed plus 3 under root times 1 over x squared. So rather than writing it as multiplied by 1 over x squared, I can just divide this by x squared, and it's the same thing. So now, as we discussed previously, we know that the power over here is equal to a half because this is a square root, and the x squared over here has a power of 2, right? So the powers are not equal to each other. So that means we cannot directly divide the square root by the x squared. So the workaround for this lies right over here. We know that the square root of x to the 4 is equal to x squared. The equal signs works both ways, so that means that x squared can be written as the square root of x to the 4. If I do that, I'm going to have a square root divided by another square root, and then we can sort of merge the square roots together, which is the main step when you do limit at infinity questions for radicals. Okay, so let's try and do that. So that gives us the limit as x approaches infinity. I'll just copy everything down. Divided by, now instead of writing this x squared, right, I can write the x squared as the square root of x to the 4. Okay, so I'll write this as the square root of x to the 4. So now this term here has a power of half because it has a square root, and this term here also has a power of half. So they are the same powers. So now what I can do is I can sort of divide them under the same square root, which sort of simplifies this whole thing for us. Okay, so let's do that. So this gives us the limit as x approaches infinity. Again, I'll copy things down, and then I apply the square root to the whole thing. Okay, so now if you try to simplify what's inside the square root, we'll have the limit as x approaches infinity of 5 minus 13 divided by x plus 5 over x squared divided by, what is 4x to the 4 divided by x to the 4, so that is just 4, minus 3x cubed divided by x to the 4 just gives me 3 over x, plus 3 divided by x to the 4, and let's not forget the square root over here. Okay, so at this point, there's no further simplifications we can do. And there's also a good chance that we might have a definitive limit answer over here. So let's try and plug in. Okay, so 13 divided by x, which is infinity, is just going to give me 0. 5 divided by infinity square also gives me 0. 3 divided by infinity gives me 0. And 3 divided by infinity to the 4 gives me 0. Okay, so that just leaves us with 5 divided by the square root of 4. Okay, so this is just 5 over 2. So therefore, we can say that the limit as x approaches infinity of our function is equal to 5 over 2. So as long as you're approaching positive infinity or negative infinity, and if our answer is a real number, we must mention that y equals to 5 over 2 in this case is a horizontal asymptote at positive infinity. Let's not forget this because there's definitely 1 mark or half a mark for just mentioning this, and this is like easy marks. Thank you very much for watching.